Okay, in this system, or this example that is, what we're going to end up doing is actually defining what's called a shear center. But that's in this Mechanics of Materials course in reality, but we're kind of setting the stage for that. That's where this real example does come from. We've got a cross-section that looks like a channel. This is called an open-walled cross-section. It is symmetric about a horizontal axis, but there is no vertical axis of symmetry. And as a result of that, we actually, if we were to apply this set of forces internally to the channel, it would actually rotate on us and warp in some interesting kind of ways unless certain things were to happen. So that's getting a little deep from where we want to go. Let's just stick with the statics part. Replace the system of forces shown with the equivalent force and couple system applied at C. Right, so we don't know where the X is, where that point C is, but what they're trying to get us to do is, if we were to redraw in simple form this channel, might look like so, and then here's our axis of symmetry that we're working with, and somewhere out here is point C. Now the easy thing on this is to look at the translational effects, right? The 900 newtons is the only vertical force here, so over here at point C we still have to have 900 newtons. Right? Now the 250 and the 250 and what we call the flanges are equal and opposite, and they're going to have no effect. Right? So that's kind of interesting. So the couple that we're talking about here is, we like to think about, well, where would we put this force out here so that there was no net effect, that there was zero couple. Right? That would be technically really the shear center. So that's not stated here. This is a little unclear in the problem statement. If I gave you the distance, then it would be easy to go figure out. You just some moments about point C and be done with this. But if we want this net effect that we have zero, then you could ask the question, what is X? Right, so that's the problem I'm really addressing here, is what is X such that the moment about point C is equal to 0. That turns out to be what's going to be effectively called the shear center, for reasons you'll find out in another course. Right? So let's go do it and really just focus on how to manipulate and work with these systems. Right? So let's just find the net moment with respect to C in our original system. Right? And so we'll sum moments, and let's take clockwise positive, and we have 250 newtons times 90 millimeters, and that's going in a clockwise way, so we're done with that one. Then we have the 250 force going the other way, but the moment is the same direction. Notice we didn't have to do these separately. We could have said 250 times 180 would have been the same effect, right? And then minus 900 newtons times our unknown distance X. And so we are going to set that all equal to 0, because that's now the condition I've stated for the problem. And so now we can just do math. Solve for X, and we'll have that 900x is equal to this 250 times 90, and then there's two of those, so that's 45,000 Newton millimeters, and X then will be 45,000 Newton millimeters divided by 900 newtons, and that's 50 millimeters. And that would be the answer here, such that the conditions of analysis are that we have no net moment about 0.